All right. Thanks so much for having me. I'm going to try to be as energetic as possible. I flew in from Newark yesterday, which the news is a little insane, but okay, this was my job market paper. This is actually probably the last presentation I get to give with this affiliation, which is kind of crazy. So what do I do in this paper? I study the trade-off between emissions from deforestation on the one hand and food production on the other. I'm going to do this in a global context, and just for motivation, the kind of carbon problem here is quite large. So in particular, the burning of forest cover in order to clear new agricultural land accounts for, depending on which IPCC report you use, between 10 and 15% of global carbon dioxide emissions. And this is far larger than the carbon footprint of, say, the entire global vehicle fleet, and about 4 times the carbon footprint of the entire global airline fleet, right? So this is large. This paper is going to think about where deforestation should occur. So this is a spatial paper, thinking about deforestation as an explicitly spatial problem. So to kind of get us thinking about where in space deforestation should occur, what I'm showing you here is a map of the carbon dioxide that's currently sequestered in trees. So each pixel on this figure is a 10 by 10 kilometer grid cell, so a square somewhere in the world. There's about 1.6 million of these total on this figure. And the more yellow or bright a particular pixel is, the more carbon dioxide is stored in that tree. And to a first order, you should think about the differences here on this figure as representing differences in the fundamental ability of land to produce trees which are carbon rich. So even if I adjust this figure, there's a button down there for the number of trees in a plot of land. You'll see that, for example, this tropical band ends up being particularly productive at producing high. Now, anecdotally, in this tropical band, where I'm saying we're really good at producing carbon-rich trees, there's also been quite a bit of deforestation since 1980. And so I want to think about this particular problem. So thinking about this spatially, I motivated this as being a trade-off between emissions from carbon dioxide and food production as the kind of counterfactual thing of interest. So a very naive first pass at thinking about where should deforestation happen says, let's put all of the deforestation on the forest with the highest yield and the lowest amount of emissions. So let's think about what that naive benchmark looks like. On the top, it's the same map that I showed you before. On the bottom, I'm showing you a map of global potential agricultural yields. You should think of this as being the yields of crops aggregated up that represent about 86% of global calories consumed. So this is capturing most of the staple crops that we consume. And what you can see, hopefully immediately, is that the same region that lit up as being very, very carbon intensive to deforest on the last figure does not light up as being particularly relatively agriculturally productive. So my naive setup, which admittedly is a bit of a straw man, seems to fail to capture where we're deforesting. And so the question of this paper is this rationalizable as like an optimal place to be deforesting? And there are a couple of reasons we might think that my naive benchmark is in fact naive. So I'm going to focus on 3 today. First, trade is very costly. So let's take the example of Brazil. If I was to take all of the deforestation out of the Amazon, presumably that food production is going to go somewhere else, presumably outside of Brazil. And as a consequence, I now have to re-import quite a bit of food production into Brazil. There's a long literature on how costly this proposition would be. Second, there are a number of other reasons that I might produce agriculture in one place relative to another. So yield is not a sufficient statistic for where agriculture is located. I might care about things like transportation costs. And then finally, when thinking about where agriculture should occur, I also have to think about the non-agricultural sector. So in my kind of candid example of moving everything out of Brazil, let's say I move every piece of agriculture that was in the Amazon to the United States, in that counterfactual story, what would happen? Well, I'd need to reallocate quite a bit of labor in the United States that might have been working in the services sector to agriculture. This might not be optimal if we think that the US is particularly good at producing services. So what do I do in this paper? I take these 3 forces seriously and I write down a trade general equilibrium model to think about where deforestation should occur. I'm going to estimate the model on the data set. I showed you a little glimpse of this earlier. I'll tell you a little bit more about it, which is going to bring together data on agricultural yields, costs, and panel data on the kind of carbon content of land use decisions involved in the deforestation problem. Why am I doing this in a model? Well, first, it's going to provide me like a really nice laboratory to think about both the actual deforestation policy space we're kind of operating in, and what I'm going to call my economic benchmark, which, spoiler alert, is going to look like a Pigouvian tax to start. And then I'm also going to use the model to then decompose how these three channels play a role in where deforestation is happening. Let me tell you a little bit about the data. I'm not going to go too into detail about this today. So I have this data set at that 10 by 10 kilometer grid cell resolution. I'm going to have carbon maps of where carbon has been stored in trees at like an irregular cross section dating back to 1980. So what this allows me to do is think about how deforestation's carbon intensity has evolved over the last 40 years. The way this works is in each of these maps, folks were sent out to actual sites to actually go and measure at breast height what is the size of this tree. And then I get a measure of carbon dioxide at, say, 10,000 sites around the world, and I generalize those insights using a machine learning algorithm. Next, I have my measure of yields. You saw this on the previous map. I'm going to be aggregating across the set of stable crops you see up here. This is motivated by this paper by Costno, Donaldson, and Smith. And you should think of this as being a potential yield. So this is rather important for thinking about how I'm going to approach identification of the model. So potential yield is not the actual yield of a plot of land. Rather, it's essentially an agronomic model of what the yield of that plot of land would be under perfect cultivation. How is this calculated? Well, agronomists went into a lab and they grew each of these crops under various soil types, various types of humidity and rainfall levels, and determined how much corn could I grow in the Amazon based on just these characteristics alone. And so these are just biophysical characteristics of land. I have panel data on land use as well, which is going to give me information at this resolution dating back to 1980, and travel time to cities and ports, which is going to get me that cost heterogeneity I mentioned. So I'm going to tell you a little bit about the model. I'm going to try to do this at some level of abstraction, but enough to hopefully give you a sense of what I'm doing. So we're going to divide the world into those parcels of land, 10 by 10 kilometers. And I'm going to think of land as having a type. The main components of that type are going to be yields, the carbon dioxide content of forests, land use starting in 1980. So this is a myopic model. I'm starting at a certain point in time, and some measure of cost, largely transportation cost. Landowners, who each own one of these parcels, are going to face a one-time discrete choice between agricultural land use and forested land use. And there's two sectors, two productive outputs in the model. One is this agricultural output, which requires land as well as a labor input. And the actual amount of agriculture I produce on a given plot of land depends on its type, its yield. Agriculture in the process also generates an emissions externality. So if I started off with that land having some amount of forest and it has some carbon intensity, that's going to determine the externality of using that plot of land for agriculture. And then there's this second sector or industry, which I'll call manufacturing. It's just basically everything else in the economy, and that competes with agriculture and use labor. Finally, on the demand side, consumers are going to consume a mix of these agricultural and manufacturing goods. They're going to be differentiated across countries, and they're going to be traded. Okay, so there's a demand system which is going to rationalize everything that's happening on the supply side of the top of the slide. So that was a lot of information, but it actually boils down to just a couple of margins that I'm thinking about. So on the landowner side, for the results I'm going to show you today, everything in black is operative. Everything in gray is stuff that I've tested that I often get questions on, and I'm happy to tell you about over coffee afterwards. So landowners in today's talk are only going to be able to change the amount of their plot of land that's devoted to agricultural production. Right? I'm using this
Sorry, before you get to the previous slide and the setup, you've referred a couple of times to the myopic framework here. Can you just say a little bit? I mean, the decision making here is likely to be dynamic. I don't know if you're using the kind of forward-looking version of the guys. Can you just talk a little bit about how the dynamics feature here and why?
Yeah, so I think there's a couple of ways you could imagine dynamics being important here. One is that I'm deforesting because I think that the yield of this plot of land is going to hit a break-even point at some point in the future. So I think that, to me, is completely fine, and that I'm just trying to rationalize, like with this myopic model, that I get above some like hurdle rate, right? So a myopic model versus a dynamic model where there's like some option value that's correlated with everything that's in my myopic model is just going to capture the fact that I need to hit some crossing point. So for that subset of the problem, I think I'm able to capture something reasonable. Where I might fail to capture
quantifying its magnitude.
What I'm going to fail to do is I'm going to fail to estimate like a fully dynamic elasticity. Is that what you mean? Yeah. So I'm not going to do that. And actually, I'll make a case that I actually think that doing that would only strengthen these results. But let me get to the estimation part before I do that. So landowners are only going to be able to change their land use decisions. So you should think of this as basically being equivalent to landowners either choosing to enter or exit agriculture. There's no kind of intensive margin of like how much of a crop I'm producing.
Once they go into agriculture, they can't go back to forestry.
They can abandon their land, but it won't regrow forest. Consumers are going to be able to do one of two things. They can change where they're buying agriculture from, or they can substitute some of their agriculture for manufactured goods. Now, in the version of results I'm going to show you today, I've adopted a completely homothetic preference. So this might feel a little bit unnatural in that agriculture is generally considered a subsistence good. I'll tell you a little bit about what changes when I relax that assumption. And then finally, I alluded to the fact that there are laborers working in the background of this model. In the baseline, workers are just going to follow land demand. So they're basically there to rationalize the factor demand that agricultural production requires. So I'm going to show you one key equation, which is hopefully going to tie what I just told you back to the introduction, which is how landowners are deciding between agriculture and forest cover for a given plot of land in the model. So on the left-hand side, I have my return as a landowner considering agricultural land use. I'm going to earn some revenue, which is going to depend on an endogenous price that I get for the agricultural output, a yield, which is given by that GAZ data, that potential yield measure. I face some cost. This cost I'm keeping relatively general, but think to a first order that this is a transportation cost for now. They're going to have to pay labor an endogenous wage. You can think of this wage as representing essentially there's some outside option to not using this plot of land for agriculture. This wage is rationalizing that fact. And then finally, there's some unobservable piece of this decision. So I'm going to put some structure on what exactly that unobservable heterogeneity looks like. So this is what things look like in business as usual. I'm basically drawing a supply curve across land that's ordering land based on yields and costs, as well as potential country level differences and say comparative advantage for doing the thing that's not agriculture. That's where the wage comes in. What changes when I start to think about where deforestation should occur? Well, in the counterfactual I'm going to consider to start, I'm going to price emissions on this plot of land at some social cost of carbon. So this is a one-time Pigouvian tax that I face if I'm chopping trees down in order to produce an agriculture. So how does this change the decision of the landowner? Well, it depends on how correlated essentially my original decision was with this new variable that I'm now forced to internalize. Just check on time. I will spend a little bit of time on identification because I got a question here. So the equation that I just wrote down, I'm kind of interested in that equation as that the kind of primitives of that landowner's decision are really going to drive my results spatially. So I turn that equation into something I can estimate. It's going to look like a pretty classic logit. On the left-hand side, I have the relative share of land that's in agriculture versus forest for a given parcel. So the observation is 10 by 10 kilometers, a grid cell. On the right-hand side, I have the empirical equivalent of everything I wrote down, price times yield, costs. I've introduced the structural unobservable, and I'll tell you why in a moment, plus some measurement error, let's call it. So the key primitive that I'm interested in identifying is the coefficient on revenue, that's highlighted in the peach here. And what does that primitive mean? It means when I raise revenue on a plot of land by $1 for agriculture, what percent more of my land uses am I going to devote to agricultural land use relative to forest? So it's a semi-elasticity. And what you can see from just a raw bin scatter here is on the x-axis I have revenue, on the y-axis I have land share. So it's not the logit form. Land share is just to keep things really close to the intuition, hopefully. you can see that this is not linear, right? And in fact, if I was to draw a line through this, it would essentially be flat, slightly downward sloping. Why is this the case? Well, I'm considering a world where there's just agriculture versus basically everything else, right? That's what I'm calling forest. The only thing differentiating, say, a city from being actual forest is its carbon intensity. So that's why there's this kind of structural error term, because the real world doesn't conform to the model. And indeed, really agriculturally productive places also tend to be the places where people have settled over time. So they're likely to be really valuable for city land use. And so in the paper, I go through a couple of different identification strategies to think about how can I separate the returns to agriculture from this unobserved amenity term, essentially the returns to being in a city. One of the strategies that I use, actually Hannah was cited in the last talk, this is another Hannah Druckenmiller innovation, is the idea of a spatial first difference. So instead of comparing things in the cross section, what I do is I say, let me take you and let me compare you to your direct neighbor. And I'm going to take differences across those two units, so me versus the grid cell next to me, 10 kilometers apart in resolution. And you can see again the rough bin scatter on the right of now differences in revenue and differences in land share. Intuitively, the identification here, the variation that's driving the coefficient that I estimate is changes in this potential yield measure, which I told you up top are driven entirely by changes in like climatological and soil variables. So the thing that you have to buy to believe that the spatial first differences is capturing by object of interest is that those differences are not necessarily being driven by the amenity itself. Or sorry, that the amenity is only driving my land share through differences in climatological factors.
What about the price in your data?
Yeah, that's a good question. So I have technically two identification challenges. One is what you're alluding to, which is that this price is potentially correlated with some aggregate level shock. Is that what you mean by it?
Yeah, but also how you even get it up single price for agriculture.
Oh, sure. So I basically construct like a Lasperes index across the set of crops that I aggregate up over. So basically there's some amount of production in a pre-period. I'm going to aggregate prices based on production shares in a pre-period.
Okay.
So back to your question, you can see that the elasticity that I get here is around 0.12. In similar papers in this land use space, the elasticity that I might benchmark myself is closer to 0.3 to 0.4. These are papers that generally take the dynamics seriously. Why do I think that starting with this elasticity is not a bad idea? Basically, what this elasticity biases me towards is a world where landowners, even when they face a very high tax rate, don't change their land use that much. So if I find particularly large effects of a Pigouvian tax on deforestation, it suggests to me that like even under a myopic elasticity, which I fully admit is likely attenuated relative to a dynamic estimator, and in fact, when I re-estimate this, it is, I'm still getting results that are kind of to a first order quite large. That's how I'm thinking about it. Okay, results. So first, let me tell you about what happens just in business as usual. So in the beginning, I showed you two maps. There was, yeah,
Sorry,
sorry.
just to be able to interpret the results. What's the objective function of the planet here and what's the level of the planet? So there's no political economy here. We're thinking of global.
It's a global social planner. They're maximizing global social welfare, adding up over basically the consumption of all consumers around the world. I'm assuming like basically unitary Pareto weights to start. And they have this additional term that the market doesn't have, right? Like when it's in business as usual optimum, where that like global social welfare has this negative, quasi-linear negative weight on damages, on emissions. So that's what generates a Pigouvian tax as the instrument of interest.
You're assuming that you can directly target the taxes to the farmers without any transmission, any sort of market power distortions from agribusiness monopsony.
Mm-hmm.
But I think there's work that shows that turns out to be quite important in understanding the political feasibility of these instruments and the efficiency.
Yeah, I'll show you a little bit on, I might not be able to show you, but I can talk a little bit about like the political feasibility of the experiment I have in mind. But I think to a first order, The thing that I'm trying to capture is just like the differences in comparative advantage when I think of yields alone versus yields and emissions alone. And so anything like what you're describing is basically going to end up being like baked into this elasticity. It's unobserved heterogeneity. So it either shows up here or in the structural error. Okay, let me tell you a little bit about results. So at the beginning of the talk, I showed you maps in terms of tons of yield and tons of emissions. What the model allows me to do is turn tons of yields and tons of emissions into returns in dollar terms of agriculture per ton of carbon dioxide. So now I can think in terms of like the dollar value of agriculture that I get per unit of carbon dioxide. In business as usual, so this is calibrating the model to data in 1980, what I see is that for when I order land by this measure of returns in dollars per unit emission, the bottom 10% of land is getting 22 times less per unit emissions than the top 10% of land. So there's this very large dispersion in the private returns to deforestation status quo. So I do a couple of exercises to understand what could be driving this based on the mechanisms I outlined for you. So here's one kind of classic example from the trade literature. Let me completely liberalize agricultural trade and see what happens. Well, kind of predictably, when trade frictions are operative, it becomes more profitable to produce at a less productive site because I'm basically reducing consumers' elasticity to what's happening outside of my country. So everywhere it becomes more productive on average. But the kind of interesting takeaway to me is that this agricultural trade channel only explains around 20% of the total dispersion in the distribution. Another rather stylized example, but one that I find interesting, is to think about the role of development, essentially, and to think about, in particular, the role of the outside option in this model. And so here, what I'm doing is I'm setting the kind of productivity of the manufacturing sector in every country very fictionally and rather arbitrarily to the United States. And the idea here is that there's this distribution of kind of the outside option, and I'm shutting down all of the variance in that distribution across countries. What I find here is, again, first of all, the magnitudes make sense. I can get more out of agriculture now because only the most productive agriculturalists are kind of competing with this outside option. And this accounts for around 50% of the total variance in the distribution. And so to me, my takeaway from this is that there's actually this case to be made. There's kind of no juxtaposition necessarily in the aggregate between development and deforestation policy. Even if in the micro, there's considerable design work to be done, to me, this aggregate number is somewhat comforting. And then the other thing that this motivates is that these frictions matter. Right? They're driving quite a bit of dispersion in the distribution. And so now when I return to my counterfactual of interest, it's not clear how much deforestation I can avoid in a world with these frictions. So my bear counterfactual is thinking about a global Pigouvian tax where the social planner is able to perfectly price the deforestation externality. I find that under this counterfactual, I'm able to avoid 97% of deforestation emissions relative to the world in business as usual since 1980. Even more so, however, or even more striking, however, is the cost of doing this. So the cost of doing this on average is around $106 per ton. Compare this with about an average social benefit. Technically, this is the marginal, but the average is not so far off, of around $190 per ton, which is what I'm taking as my social cost of carbon. So there's significant social surplus left over, even after accounting for these frictions, under the Pigouvian tax, right? So it's not the case that I kind of hit that super marginal producer where the cost is extremely, extremely high. The remaining carbon dioxide that is still emitted under this counterfactual is now emitted in places with higher return, I should say higher return per carbon dioxide, subtropical forests. So who's the marginal emitter if I want to expand my production? It's a producer in Mexico or China rather than a producer in, say, Brazil.
How much of the 97% is because you reallocated the deforestation versus because there's just less deforestation?
Oh, that's a good question. Yeah, so I would say about, if I completely shut down kind of the ability to, I would say basically it's like 80% is like stopped deforestation essentially, and around 16–70% is reallocation. Yeah. So My final counterfactual is what I hope is a step towards thinking about the current policy space of deforestation. It's a bit stylized, but because I'm thinking about carbon taxation, I have to think in a somewhat stylized fashion because most carbon taxes and markets don't actually cover agriculture, let alone deforestation. There's two exceptions. There's New Zealand and most recently Denmark, I believe, has a proposal to do this. If I take those that current landscape of actual carbon taxes and markets, which have been applied to a number of industries rather than deforestation, and I apply them directly to deforestation, I find they yield only around 5% CO2 reductions relative to business as usual, but cost $22 more per ton than the Peruvian. So the idea here is that the current landscape of carbon ambition is potentially mistargeted for thinking about the deforestation problem. So there's huge gains from trade when we think about carbon policy in the deforestation space. I think I'm at time.
Oh, we have 5 minutes left.
Oh, incredible. So I'll wrap here and take questions because I think this is a good place to leave it. So my 3 takeaways from the paper: first, deforestation-related carbon dioxide policy can overwhelmingly reduce CO2 emissions at a limited food cost. My second takeaway is that current carbon taxes are likely not targeted well to do this. And so my third takeaway is that there's likely room in the aggregate for thinking about policy which coordinates development and deforestation prevention. I have a little bit of time, so I can tell you a little bit about some extensions, but I'll start with questions maybe.
So one of my key takeaway of the paper was it's quite thought-provoking. Essentially, in the global, we have way too stringent policy to protect forests, and essentially you're saying, hey, this is not optimal. And so how about you have unilateral policy and tell experiment US just 100% go agriculture. What's the GE effect of that? And that would be very interesting. Reduction of wildfire. You can, will be actually more forest or less deforestation because of the GE effect of price. For example, North still consume meat, but then it produces elsewhere. Without thinking about, this will have like climate effect, right?
Yeah, right. So I think that, so I think your general intuition is right, which is that one takeaway of this paper is that if I could produce more agricultural consumption in the global north, so like land use portion of the welfare problem would be significantly ameliorated, right? What I actually find though, like just to put a little bit of nuance on this, is a lot of the reallocation is actually happening within country. So I might have I don't know if I want to click on the button, but it's that I do a cost-effective version of this where I shut down the ability to move production overseas. So I basically say you now have to produce exactly as much as you produced in business as usual in Brazil, in total. You can reallocate as much as you want within Brazil, but in total, Brazil is producing as much as Brazil does. And I find that I'm still able to recover on the order of magnitude of like 67% of those initial gains. Right? Because a lot of this is still reallocation from, for example, the Amazon to the Atlantic forest region, which is less carbon dense and was deforested early in the 18 and 1900s or so. So there's still ground for reallocation within the context.
So just one, I guess the big question is, how do you stop people who want to do agriculture from doing it? Your paper presumably isn't getting into that.
No, I always get a version of this question, so I always say like, stay tuned, because I am thinking about this, but yeah, this paper is really just about, in some sense it's a bit descriptive, right? It's telling you where should deforestation happen, and then like, let's think about the policy to do that. My concern is like, when I got into this paper, there was like, to me, an aggregate question that felt a little missing, which was like, I kind of have a sense the Amazon is really bad to deforest, but what I don't have a sense of is when I reduce deforestation in the Amazon, what that does to the Congo River Basin deforestation, for example. So that's what I was trying to round out in this paper. Great, thanks so much.